left off the last video at just one more step to go to get it where it needs to go. It needs to go from this point here to that point there. So that is a translation down by 1. So our y coordinate, which is 2x plus 1 here, is going to be minus 1. And to the right by 6. So we're going to add 6 to our first coordinate, which is our x coordinate, even though it says y. So we're going to have negative 2y plus 6. And then our y coordinate, 2x plus 8. I'm going to subtract 1 from that. So 2x plus 8 minus 1 is 2x plus 7. And that is my composite function. Now let's go ahead and compare that to what happens with each set of points. So our first transformation is y comma negative x. I've gone ahead and written in the pre-image points that match the black figure, TRANSF. And the first transformation, I'm going to take all of my first column, x's, and they're going to become negative my second column over here, my new y's, and all my y's are my x's. So I'm going to write, first I'm going to write down all my y's as my x's. So this becomes 1, 1, negative 1 half, negative 1 half, negative 1, negative 1. So that was easy. But now my y's are what used to be my x's, but changed the sign. So negative 1 half, 0, 0, positive 1 half, and then positive 1 half, and then negative 1 half. So I've changed all that. That's the transformation. This should all land in these points here, where my r prime, t prime, blah, blah, blah are. And now my next transformation, I'm going to do in red to match what I did over here. And it says y comma, oh, you know what? It actually says, if I go down to the blue, it says that this whole red thing simplifies to y comma x plus 8. But what I have to be careful of is that's taking these numbers, these original numbers, and making it y comma x plus 8. So if I want to transform the purples to the reds, I need to use not the rule I wrote, because the rule I wrote incorporated the prior numbers. So I'm just going to go ahead and always start with my black numbers, my TRANSF, and then turn them into my red numbers for the second transformation. So again, I'm going to take my y's, and they're all going to stay the same. 1, 1, negative 1 half, negative 1 half, negative 1, negative 1. And then my x's, I'm going to keep my x's, oops, yeah, right. I'm going to keep my x's from this column here and write, just add 8 to them. So 1 plus 8 is 9. 1 plus 8 is 9. Oh, those aren't my x's, those are my y's. Shoot. So, sorry, my x's are the first bit. 1 half plus 8 is 8.5. 0 plus 8 is 8. 0 plus 8 is 8. Negative 1 half plus 8 is 7.5. 7.5. And 8.5. And now if I look at where these points are, my t should be at 1, 8, 8.5, I'm sorry, which is this point right here. I don't know if you can see my cursor. Then 1, my r should be at 1, 8. Yep, 1, 8 exactly, right? So 1, 8.5 for t prime, double prime, 1, 8 for r double prime. Then a should be at negative 1 half, 8. Yep, it all seems to work out well. So my next transformation to get to t triple prime, I believe I did that in light blue here, And again, I'm going to take these coordinates, these x, y's, and I'm going to plug them through the formula. Let's see, what was my blue formula? Oops. Negative y comma x plus 8. So what I'm really doing is taking all of my prior ones and just changing the sign of my y. Oops, not what I meant to do. So if I take my prior ones and just change the y, or if I take my original ones and make them negative y comma x plus 8. So negative y comma x plus 8. Great. So really, that's the same thing as taking those numbers and just switching the x coordinate to negative, because I look at the difference between this, and the only thing that changed was the negative. So it's going to be negative 1, 8.5, negative 1, 8, positive 1/2, 8, positive 1/2, 7.5, positive 1, 7.5, and positive 1, 8.5. Okay? Now, the next one was this messy thing. Okay. That simplified to the gold rule down here that I started with, negative 2y comma 2x plus 8. So I can take all of these points and plug them in as negative 2y comma negative x plus 8. I believe that was the rule. Negative 2y, positive 2x plus 8. Okay. Positive 2x. That's what I was missing, the 2. All right. So my rule is negative 2y comma 2x plus 8. I'm just going to go from the original numbers. And so negative 2y, this is my y, so that's going to be just negative 2. That's going to be my first number. Again, I'm going to do all the y's first, all the first coordinates, the x's that are negative 2y. So again, negative 2. Now I need to take negative 2 times that, which is a positive 1. And the next one's the same. And negative 2 times negative 1 is positive 2, positive 2. So that should give me my x coordinates. That should match my green shape up here. It looks like everything is at 1 or 2 or negative 2. So that looks very promising. Now my y coordinates come from my x values. So I have to double half, which just gives me 1, plus 8 gives me 9. Double 0 plus 8 gives me 8. Double 0 plus 8 gives me 8. Double negative 1/2. Again, I'm not changing the sign this time. It's just double. So that's negative 1 plus 8 gives me 7. Same for this one. And then double 1/2 gives me 1 plus 8 gives me 9. So that should set me up. Yeah, that looks promising. All of them at 7, 8, or 9. 7, 8, or 9 over here. Hopefully you can see my cursor. Great. And then that last transformation is going to be the final one in gold. Negative 2y plus 6, comma 2x plus 7. So I could go through and do all that math, or the other way, and I know you get sick of me talking about other ways, but there's always other ways, is to say, well, if I take these, all I did was add 6 to the x's, so x plus 6, and add, 1? No, subtract 1 from the y's. So if I wanted to do the partial step rule, that's fine. The gold one takes me from my original all the way to the end, but I can think about it as a partial as I'm calculating these points, or I can just plot the points of T5. But I want to make sure it makes sense. So x plus 6, so negative 2 plus 6 is 4. 4, 1 plus 6 is 7, 7. 2 plus 6 is 8, 8. So does that make sense in my original position that my x's are 4 and 4, 7 and 8? Yep, it does. Okay. And then my y minus 1, so this is 8, 7, 7, 6, 6, and 8. And there you go. Those are the heights of all of the points in my final. Now there's one more thing I wanted to show you, and it's from, it's to check my math for the gold rule here. I've gone over to Desmos and plotted each of these points one at a time. And so you can sort of see my shape here, TRANSF. I've also put them into this table so that I could operate on them. So the table points are here. They overlay the points that I plotted up there. And now I can act on them using the table reference x sub 1 and y sub 1. And so I've typed in my formula, negative 2y1 plus 6. That's what I got in my gold, negative 2y plus 6. And then 2x plus 7, 2x plus 7. That was my final rule. Now hopefully it'll take this original shape and put it directly onto this final position that I'm looking for. So let's see what it does. There it is. Woo! Look at it. It's so pretty. And so that is my, that is the actual transformation that lands it exactly where it ought to go. See, the back of it's on y equals 8. So 1, 2, 3, 4, 5, 6, 7, 8. Yep, the back of it's along y equals 8. And the far side of it's along 1, 2, 3, 4, 5, 6, 7, 8. Yep, 8, 8. So this point should be 8, 8. Yes, it is. Yay! So that makes me feel better, and it also shows you why we bother with all of these composite transformations, because it can take you straight from the beginning to the end in just about any path you want to take. Because I didn't pick this path specifically because it's the best path, and I realized as I was making the video I should have dilated first while I was on the origin, but it all shakes out in the end in that simplification process as you go through. So good luck, ask all the questions in class, and see you there.